So here we're given the number of passengers on 9 flights, and these numbers are 22, 33, 21, and you'll notice they're not arranged in increasing order, so I have to rewrite them to answer the question. So the smallest is 19, and then 21, and then I have two 22s, so those are out. The next value is 28, and then 31, then 33, then 44, and 50. So here's my data in increasing order. And it also, the problem tells us that the standard deviation is approximately 10.2. And in A, they ask you to find the mean. So I'll start with mean. So mean would require me to add all these up. So that's 40, 44, so that's 84. And that's 59, and these two add up to 77 and 50. So 9 plus 7 is 16, and 4 is 20, 10, 15, 22, 27. So the sum is 270, and I have to divide this by the number of data points, which is 9. So 270 over 9 is 30. So the mean is 30. Then we're asked to find the median. So there are 9 data points, so we will have a middle point, which is 28. So the median is 28. And mode, which is the most frequently occurring data point, there are two 22s, so the mode is 22. And the range, which is the difference between the greatest and the least, is going to be 50 minus 19, which is going to be 31. And then I have to compute the interquartile range. So I have to divide this data. The second quartile, which is the median, Q2, is 28. And then Q1 is the median of this half, and the median would be the average of those two numbers, which is 21.5. And Q3 would be the average of these middle two, so average of 33 and 44, half of 77, which is 38.5. So the interquartile range, which is the difference between Q3 and Q1, would be 38.5 minus 21.5, which is 17. So now we have to answer B, where we're told that if there had been 3 times as many passengers, what happens to the mean, median, mode, range, and interquartile range, and the standard deviation? So anytime you triple the numbers in the set, the mean triples. So the new mean would just be 3 times that. So the new mean would be 90. And same thing for the median, because each number in the set is going to be triple. So the new median is 3 times 28, which is 84. And the new mode also goes up by 3 times, because we are multiplying each number by 3. So these two 22s would become 66. So new mode is 66. And the range will also triple, because I'm going to triple these numbers in the extreme. So it becomes 150, and this number would become 57. And their difference is 93. So the new range is 93. And then the interquartile range, because each of these Q1 and Q3 would also triple, the difference would triple. So that would go up to 51. And then the standard deviation, when you multiply a set of numbers by the same number, the standard deviation also goes up by that amount. So it would be 3 times 10.2. So it would be approximately 30.6. So those are the answers for B. Now I have to do the same thing for C, where what we're doing is if we had 2 fewer passengers, so that operation is the same as subtracting the same number from each of these data points. And the question I was asking is, what would happen to the interquartile range And in this case, the Q1 is going to go down by 2. So that would be 19.5. And then the Q3 will also go down by 2 points, so it would be 36.5. But their difference will remain at 17, so the interquartile doesn't change. And same thing for standard deviation. When you subtract a fixed number from each of the sets, the standard deviation remains unchanged, so it would stay at 10.2.